think, as I mentioned this to a couple people, even hams were surprised that there were other people using the HF bands other than ham radio operators. Shortwave broadcasters around the world are closing up shop. You might think that military users and hams are the only ones on the high frequency bands, along with maybe some Cold War spies who are listening for some numbers stations. But airliners that make oceanic crossings are relying on HF bands every day, relying on communication over skywave, and use very many of the frequencies that are similar and adjacent to the ham bands, all the way from 80 meters up through frequencies that are close to 15 meters. Depending on propagation, they get assigned different frequencies. So what I'd want to go through today is talk a little bit about that communication system, and we'll track an aircraft that's leaving from Los Angeles and headed to Sydney, Australia. The system that they use is something called AirInc. So you all know what ATC is, air traffic control, and aircraft that are traveling over the continent are speaking in contact usually with air traffic controllers most, if not all, of their flight. But as you head out over the ocean, obviously, once you get out of sight of land, line of sight communications no longer work. So Collins Aerospace, which is now a part of Raytheon Technologies, but since 1929 has been providing aviation services to the FAA for HF and VHF voice as part of AirInc. And surprisingly, you'd think with satellite technology and digital networks that we might have migrated our primary communications over to those networks, but the primary means of air-to-ground communication during oceanic flight remains AirInc and the HF frequencies. They've got two stations. One is in Livermore, California, and the other is in Islip, New York, so Atlantic and Pacific Ocean. And I'll just quickly go through what the anatomy of a transpacific flight looks like. So an aircraft that's departing from Los Angeles is going to initially make contact with Los Angeles ground, tower, and then Southern California Terminal Radar Approach Control, or we call TRACON, and then Los Angeles Center, which is abbreviated ZLA. So those are the typical elements of an aircraft departure. And don't look any different from an aircraft that's heading to New York versus one that's heading to Sydney. Where it starts to get interesting is when they switch over to San Francisco AirInc. And that frequency is 131.95, 131.950 megahertz, but it's AM. And I'll talk a little bit more about how you can receive those frequencies if you don't know how to do that already. There's a few different options. But if you're interested in hearing airband frequencies on VHF, it's quite easy to do with existing ham equipment oftentimes, or even with a smartphone. San Francisco AirInc will give them high frequency communications frequencies, channelized frequencies, using coastal sites for communication. And typically those frequencies tend to be 5 and 8 megahertz when you're listening during the afternoon and evening hours. And we'll hear what some of those sound like. They also do a cell call test. Cell call stands for selective calling. Us hams, we're used to listening to all the static and the noise, and kind of may even get some enjoyment from pulling weak signals out of the noise floor. But pilots have a lot of other work to do, and they don't necessarily want to listen to unsquelched audio from upper sideband. So cell call is actually a tone system similar to a fire department paging that allows the AirInc operator to send some tones to the aircraft, and that would allow them to open their squelch, and then they can page that particular aircraft. So each aircraft's assigned a discrete cell call code, and then they can open the squelch and then say, American 9711, this is San Francisco AirInc, and then they don't have to hear all of the other calls and the static and whatnot. So it's just a matter of convenience. So little slides here got out of order. What we're going to do is listen in on American 9711. This is a flight from earlier this week. They departed Los Angeles at just after 10 p.m., headed for Sydney, Australia. It's a 14-hour flight. nearly 15 hours long, 14 hours, 24 minutes. And most of the time spent out of water outside of VHF line of sight contact. So they have these HF frequencies to contact and then contact AirInc and then report their position over the water. Of course, as they get inside of Hawaii, there's ground stations there that they could contact on VHF. And they typically tend to go within a few hundred miles of Hawaii for this particular route that American takes on. I believe it's a nightly flight. Yes, there are SAT systems out there and there's data systems, but HF is still that primary means of communication for those reporting points, and they must check in on HF. Every Oceanic aircraft must have high frequency radios for their transpacific crossings and transatlantic crossings. So we're going to listen in. American 9711 Heavy is the call sign. If you've ever listened to ATC communications before, you might have heard that heavy. It just means a maximum takeoff weight of 136 tons or greater. And it's to alert ATC to a large aircraft, as well as other aircraft in the area might be concerned with wake turbulence, which is similar to a wake from a large ship on the ocean. So it's just to let people know it's a big boy. So let me switch over to the let's see, how do I do this? Switch over to the video. Okay. All right, so this is a screen capture from our earthspot.net system that Brian introduced a few minutes ago. If you've ever used an aircraft tracking site like FlightAware to find out when your relatives are arriving at an airport or just see what the status is, whether an aircraft is late, you've probably seen the moving map on there. It's gotten better, but oftentimes the moving map, because of the way the system functions and their agreements with the FAA for some vestigial national security reasons, it can be delayed. It's basically a policy holdover. There are now sites, and obviously we can receive these aircraft position from a system called ADSB, which is similar to APRS for hams, which is a GPS on the aircraft. It gets the position of the aircraft, and then it sends out that position over the network, over the air, which is then ingested by network receivers and then puts the position on the map. So prior to ADSB, all aircraft tracking was done by air traffic control with radar. And of course, you've seen movies with the radar sweep in the radar room, and the controllers are looking at it. Now radar is augmented with this self-reporting system, this broadcast of ADSB from aircraft. The cool thing about ADSB is anyone can receive it, and the Radio Club and now our sister organization, Santa Barbara Wireless Foundation, which does all these sort of ancillary, non-ham related data gathering things from our repeater sites around the region, allows us to, from Santa Ynez Peak, from Diablo Peak on Santa Cruz Island, and we have some hams down in San Diego and Ventura counties that are also feeding our system. It allows us to see aircraft oftentimes from the ground all the way up to several hundred miles to sometimes even more than that offshore as they make their transoceanic crossings. So I'm going to play for you some audio that was recorded from the VHF and HF bands, and we're going to track live, or recorded live, this aircraft 9711, American 9711, as it departs Los Angeles and heads out over the ocean and makes its routine radio calls from VHF and transitions over to upper sideband on HF. And I've sped this up. This took me about an hour, 45 minutes to capture. I've sped it up to about 3 minutes, and I'll periodically stop and try to explain what's happening in the present in the radio.
American 9711 Heavy, wind 070 at 6, RNAV Docker, runway 25 right, clear for takeoff. RNAV Docker, 25 right, cleared for takeoff. American 9711 Heavy.
So that was Tower basically giving them their departure instructions. RNAV DACA is some sort of departure instruction that you could look up, and I'll talk a little bit about that later. But that's their basic clearance to depart from Los Angeles.
American 9711 Heavy, contact SOTA departure. Good night, y'all. Good night, American 9711 Heavy.
So you can see them there just above the seal, 9711 Heavy. They've departed. They're showing up on our map, and that was LA Tower. So actually in the tower cab on the at LAX, handing them off to the radar room. So instead of talking to someone who's looking at them on binoculars, now they're talking to someone who's looking at them on the screen, called LA Departure. That's in the TRACON facility, Terminal Radar Approach Control facility. So they're looking at a screen similar to this, a little bit different with the data, but basically, you know, a map with aircraft moving on it.
And SoCal, America 9711 Heavy, 1.8 climbing via Summer 2, except maintain 5,000.
So 1.8 just means 1,800 feet and climbing via this Summer 2 departure procedure, which is a route that they fly, which looks like basically straight out from Los Angeles out over the bay.
American 9711 Heavy, SoCal departure, low radar contact, climb via SID, top altitude flight level 230.
They say climb via the SID, SID, Standard Instrument Departure, except they gave them a top altitude to climb to.
Climb via SID, top altitude, flight level 230, and request high-speed climb, American 9711 Heavy.
American 9711 Heavy, approved as requested.
Approved as requested, American 9711 Heavy, thanks.
So here's a little speed up. Originally, I was going to track this Delta Airlines 41 right behind them, but they took forever to contact AirInc, so I ended up using American 9711 instead. They're both going to Sydney, Australia. They're both following almost exactly the same route, and it's interesting that the competing airlines have these departure windows that they seem to all crowd around. Like all the flights to Sydney are leaving at exactly the same time or within 5 minutes of each other, and I think it has to do with connections and arrival times and just between traveler preference and lining up with other aircraft schedules. So that's my best guess anyway. I don't know exactly why they all fumble to get in line to go to Sydney all at the same time, but they do.
And Oakland, American 9711 on 131.95, looking for the freaks this evening.
So he called it Oakland. It's actually San Francisco. He corrects himself in a second here. 131.95 is that AirInc that I talked about. So prior to this transmission, he was talking to air traffic control. Now he's talking to AirInc, which is that Collins private contract frequency where he's going to get assigned his Oceanic HF frequencies. And I should have mentioned this a little bit earlier. The reason that this really got interesting to me was that when you listen to the HF transmissions, they're not even 200 miles offshore from Santa Barbara here, and depending on propagation, they become like beacons, single sideband beacons for you, so you can tell what's going on. Say if they get assigned to 8 megahertz, you can kind of say, well, that's similar to 40 meters on the ham bands. And if I can hear this aircraft that's 100 miles away or 1,000 miles away on 8 megahertz, then that means 40-meter voice is probably open as well. So they become these moving target beacon network for you to tune around and see, well, how's propagation doing on the band? So we'll see what frequencies San Francisco AirInc assigns American 9711 Heavy here.
Sorry, San Francisco.
Please stand by for the next available radio operator.
I was so glad I got that. You get a hold message if they're busy. Interesting.
Yes, San Francisco, it's American. Delta 41, clear at 131. Delta 41. This evening. Copy.
So it's a little muffled to hear him, but bear with him. It does get better, and he repeats everything that the AirInc operator says.
Primary will be 5574, secondary 34013, and crossing 15 north, 15 north, primary 5643, secondary limiting 67. Got it. Okay, 5574 on the primary. I missed the secondary, but at 15 north it'll be 5643 and 8867, so I just need the secondary now. Okay, secondary this time 3413, correct? 3413, good night.
So 8 megahertz or 5 megahertz and 3 megahertz, and we'll hear him make his initial call here to San Francisco AirInc on 5574 kilohertz, USB, upper sideband.
San Francisco, American 9711 on 5574. American 9711, San Francisco, continue this frequency, primary, secondary, 341 tree, and crossing 20 north, primary frequency, 564 tree, secondary, 8867.
Sounds like he's got YouTube on in the background creating a feedback loop. So he gave him a couple frequencies there. On the next screen, I'll show you a map, but he's talking about as you cross lines, as you cross different latitude and longitude lines, you're going to be using a different frequency. So he says after crossing such and such, he gives him a different frequency. That's something that he makes note of, and then we'll handle further on in the flight. It's probably not for a few hours down the line. So this is just negotiating those frequencies, making sure they've established contact. You'll hear him say this frequency primary, secondary, and he confirms that secondary 3 megahertz frequency. You start to get to understand the language of the exchange. Similar to a contest exchange with hams, they kind of have a routine. They say a lot of the same things. As I started listening to it and hearing more of it, I was like, some of this could just be a recording. It's almost like an answering machine. They're saying the same thing to every aircraft. If you wait for Delta 41 just in trail of American 9711, you'll hear almost an identical exchange of information. There's the cell call tones. They're testing the cell call now.
And good set, American 9711 is 3413 on the secondary now. And verify 20 north, 5643 and 8867, is that correct? That is affirmative, sir. Thank you.
American 9711, heavy contact LA Center 119.05.
American 9711, heavy, good night.
So that's his last contact with SoCal Tracon, and he does check in one more time with LA Center, and then he's out of contact with the shore, and he's on HF for the better part of 14 hours until he is within range of Sydney on VHF, and then he'll make an initial call up and do the whole thing in reverse with the approach controllers in Australia. Let me switch over back to the slides here. Okay, this is that chart I was showing you there, and obviously that's the route of the flight underneath, and then we lay this chart over the top here, and it shows you the different quadrants that the aircraft travel through. And again, I'm going to put this all online so you'll be able to download it and examine it more closely if you're interested in making note of these frequencies, so don't scramble to write them down. You can see that as there are those lines of latitude and longitude. As they cross them, they'll be assigned a different frequency or a different pair of frequencies depending on time of day and propagation in the different boxes until they make their way down to Australia. And all these are operated by stations on the coast. And I'll talk a little bit more about how they likely do that, and maybe RQV can answer some questions if he knows how this works. But of particular note is that here in Santa Barbara is where one of those stations are. So I mentioned 13195, I think was that, 13195 AM is where they make that initial call up from. And you can hear that on VHF because the transmitter that they're talking on and the radio site is in Santa Barbara. It's west of LA, so it makes sense not to put it in LA, even though the flights are departing from Los Angeles, because Santa Barbara is west, so it's going to be closer as they make those initial call in. And there's another site up in San Francisco Bay Area for departures from San Francisco International and Oakland as well. Note that all the frequencies are USB. They don't follow the ham radio tradition of lower sideband on frequencies 40 meters and down. It's all upper sideband. And I believe the aircraft radios are locked on upper sideband, so I don't think they can go on lower. At least the ones I've seen didn't seem to have that. Again, radio site in Santa Barbara, cell call on HF and VHF. They kind of label all of the different things that happen here. And this racetrack looking thing is likely coverage that you'll see of VHF. That's their VHF radio horizon, or their expectation of how far out they'd be able to use it. So here are some more resources if you're interested in listening into some of this stuff on your own. I used the site FlightAware, flightaware.com, and you get the top of the screen, you can search for an airport. I just put in KLAX, which is the international code for Los Angeles International Airport. Most of the US, I think you can use the 3-letter code as well. You could just type in LAX. And then I go to the departures section and look and see what's departed, and then they have scheduled departures after that. If there's not enough shown there, or you don't see any international departures, you can always click more and go to a secondary screen. And I'm just looking for something typically that's departing around the time I want to listen. I found just this week in looking at the schedules that many of the departures to Down Under, which is where you want to make sure that some of the flights that are going to East Asian countries are taking a polar or a Great Circle route going up by Alaska. And so you won't necessarily hear them check in the same way. So I'm looking for ones that are going south. I want to hear aircraft that are headed to Australia, New Zealand. So I'm looking for those departures on the screen here. And then once you find the departure, you just wait for them to depart and look for them on the earthspot.net website, and wait till they check in. Now, how you're going to listen. For VHF, for 131.95, and if you're interested in hearing just the domestic departures out of Santa Barbara, you can likely use your VHF ham radio. Most ham radios will tune the airband, and they'll go down there. Now, I've heard a couple people ask me on a couple of the nets. They said, well, I don't think mine does that. What did you do? Sometimes you have to enable wide RX coverage, wide receive coverage on particularly Yaesu radios come where it's an option, but it just needs to be unlocked. And that can be done in the configuration screen. Just change the coverage to wide, and it'll automatically let you go down lower than the ham bands, and you can receive on AM. And then if you're looking for frequencies, this website, skyvector.com, will have frequencies for different airports. You can just type in the airport code again, and you'll get a list of all the frequencies down here. You'll get the charts, which also have frequencies printed on them. So that can be a helpful place to stop as well. Now, if you don't have a VHF radio, or you want to hear radio traffic from an airport that's outside of your radio horizon, then liveatc.net has a network of feeders that are basically just scanners, virtual scanners feeding their network and streaming it online, similar to the way we stream our repeaters. So a couple of those LA calls I actually didn't pick up directly. I just downloaded from the archive here at liveatc.net. They have an Android and iOS app, and they have a website that lets you do it. It's very comprehensive, and there's a ton of airports that are on there, particularly all of the big ones. And even Santa Barbara has some live streams on there. Now, when you get to the shortwave and the AirInc high frequency frequencies that you'll want to tune in, most HF and shortwave radios tune those frequencies out of the box. Just remember that it's upper sideband, not lower sideband. Your radio may default to lower sideband. And I thought, geez, there's nobody on these frequencies. Of course, it was on lower sideband because my radio defaulted to that. So if you're going to listen on your own, just remember to put your radio in upper sideband. Those frequencies for AirInc can be found on this site, radio.airinc.net/Pacific. This site also has those maps that I showed you. There's even a document for, if you really want to get into the weeds with this, the Aviation Voice Services Operating Procedures Handbook. It's written for pilots and schedulers and dispatchers at the airlines to read and understand how the system works. So all of it's public, all of it's documented. It's really, it's not secret what's happening here. Here's this map that I showed on the screen as well. So both of those documents, and these will be hot links in the PDF when I put it on the website. If you don't have an HF radio, or in the case of that night, I was not picking that American 9711 up all that well line of sight on what I guess would be considered close to 40 meters. So I decided to see, well, how well can I hear him in Utah? So I went to the web SDR in Utah, and I was able to tune the frequency there. Obviously, that's not displaying the correct frequency. I was on whatever he was assigned, 5574, and I could hear him better in Utah over the just off the Santa Barbara channel than I could here in Santa Barbara. And that just varies on propagation. I've heard them perfectly here in Santa Barbara other nights, and probably as he got further away, he'd probably come in better for me here as the distance between the skip angle and ionosphere changed. As the night gets later, they may fade. So my guess is that the FAA probably has, or AirInc, I should say, probably has multiple transmit and receive sites for HF that are at different longitudes, different latitudes, to try to make sure that they always stay within range and within the skip range of the various aircraft. So worth checking out the web SDRs to listen to these frequencies as well. You can even make your own recordings. What you heard came from a recording right here. They'll let you download a WAV file. It's very cool. We've looked at earthspot.net. I can put it up on the screen again in a minute, but let me just show you what one of those feeders looks like. It's kind of a cool homebrew-ish project. It's off-the-shelf parts, so it's not really all that homebrew, but you stick them together and it's pretty cool how it works. This is a Raspberry Pi. This is we call it, it's an ADSB receiver, but really it's a $20 RTL SDR dongle. They're made overseas. They were intended for use in Asia for receiving TV signals off the air. They're a $20 device, and they can be repurposed not only for ADSB, but scanning and listening of frequencies from like 30 megahertz to 1 gigahertz or even higher. So we put a filter on it to filter out 1090, which is the 1 gigahertz frequency that the aircraft are using to send their position data. And that's how we feed the map. It's less than $100 in hardware, and we're able to capture the location information from the airplanes, put it on a map, and it's live. So let me pull up that. Let me pull up earthspot.net one more time. That did not work the way I wanted it to. Hold on. Yeah, here it is. So here's the live look at those aircraft. And like I said, FlightAware and some others, Flight Radar 24, you've probably heard of, that's often delayed. If you were out over Isla Vista, well, what's going on right now? A little lag here. Yeah, let's say if you were at El Cap or out by Naples, you would be seeing ExoJet 350 fly over your head at this moment. This is exactly where that aircraft is. There's no delay. We don't introduce any delay. So it's very good for tracking aircraft, particularly if there's a fire in Santa Barbara. We watch sometimes the helicopters will circle overhead of different sites where the fire is. And sometimes we'll hear conflicting information. You'll watch the news and you'll say, oh, they're done for the night. They're not going to make any more drops. And we're sitting here on earthspot.net watching them dunk into Lake Cachuma and make second or final drops. So it's really cool. And you know that what you're seeing is live. It's not delayed. So that's the reason to use earthspot.net over some of the other services that are out there. You go down to Los Angeles and you'll see it's getting busy. Now's the time where some of those departures start to tick up, and then I think they peak at around 10 p.m. Those departures to Australia and New Zealand. On the little data block here, you'll see it says Diablo Peak. That means that that's the receiver that it's coming in on. So feel free to check it out. It's earthspot.net. You can see our different receive sites here. You can actually choose which site that you want to receive from. So if you want to see, again, what does 1 gigahertz propagation look like? You can choose, okay, what can I see from Santa Ynez Peak? And you'll be amazed at what the radio horizon is when the station is at 30,000 feet. And I'll pull this up so you can see just the range of how far our system goes. I mean, we're tracking them well into Mexico and up into Northern California and then way out onto the ocean. I mean, imagine Santa Ynez Peak is picking this aircraft up and they're well into international waters. I mean, I don't know how far that is, but it's a few hundred miles anyway offshore, and they're still on the screen. gonna flip back for my final couple slides here, and then I'll take questions if you guys have any. So my next challenge, what's up next? Some of you might be interested in tackling this yourselves. ACARS, which is an aircraft communication addressing and reporting system. It's a digital system similar to ADSB, but much older. It's been around for many years. What it does is allows a data, like basically a text message exchange between aircraft in flight and ground stations, usually company, like Delta can call Delta dispatch and find out what gate they're coming into or that sort of thing. It also has lots of automated reporting, like when the gear comes up, when the gear goes down, when the flaps come up, when the flaps go down, what the pressurization looks like. It's a diagnostic system. It's similar in some ways to onboard diagnostics, the OBD system on cars that reports everything, you know, the heartbeat of the car that's happening. This is a digital data downlink that allows the aircraft operator, the company, the airline, to see what's going on with their fleet live. When they're out over the ocean, well, when they're over the continent, they use VHF. When they're out over the ocean, they use HF. And this system allows them to track the fleet even as they're on these oceanic flights. Interestingly, when they switch to HF, obviously the bit rates and the data rates go down, but it can be demodulated by anyone. It's not encrypted. At least I don't think it is. Most of the time it's not. The modulation can be 2 PSK, 4 PSK, 8 PSK with bit rates from 300 to 1800 bits per second. And the airline operational controller, pilot data link communication, and they even send ADS messages, which are like ADSB, which report their position automatically over HF, which is kind of cool. So something to check out. There's a presentation here, or a short video here. It's 8.5 minutes long from a YouTube channel called Tech Minds, and he goes into all the details about what HFDL or high frequency data link is. Again, that link is going to be clickable if you download the PDF from the website, and you'll be able to get a quick summary of what HFDL, high frequency data link, is over ACARS. So that's the next thing. Thank you all for your attention during the presentation, and happy to answer any questions if you have any.